Hello everyone, welcome to part 4 of lecture series of numerical matrix methods for solving the system of linear equations. Uh, Now for simplicity, I'm going to consider the system of three equations in three unknowns, but the same procedure is applicable for 4 cross 4, 5 cross 5 or up to n cross n matrix system of linear equations. So what we do next is now once we have the system, we are going to rewrite the system in the matrix form in this way. This is the coefficient matrix, the solution matrix and the constant matrix. So therefore we get this as a compact form. Now how this Gauss Jordan method works. So we consider the compact matrix form of the given system, and then what are these arrows? These arrows are nothing but they are actually row transformations. Okay, I think all of you must be knowing what are the row transformations. So when we apply this row transformation on A, uh, we are supposed to convert this A to I, and the simultaneous row transformations will be also applied on B. So therefore when we do this procedure, what we do is we transform A to I and we transform B to some matrix, say B1. And when we do that, finally since I times x is x, we get the solution as x equal to B1. Okay, let us look at one simple example again for a system of 3 cross 3, that is 3 equations in 3 unknowns. So let us rewrite this system in the matrix form in this way. If you want, you can pause and check whether the system written is correct. When we do that, what I'm going to do is I'm going to come to use the augmented matrix form from this system. So you can see I've written this matrix A. Okay, this is the augmented form, and this matrix B here, and then I'm going to start performing the row transformations. So you can see here that in this matrix 1 is present here, and since I want to convert this matrix to identity matrix, it means that I should have 1 here, 0 0 0 1 0 0 0 1. So to achieve that, what I'm going to do is first I'm going to use this transformation, that is R13. So R13 is interchanging the first row to third row. So after that transformation, I get this matrix. If you want, you can pause and see if this is correct. Okay, so we got this matrix in the previous step. So what I'm going to do is now I'm going to make this and this entry to 0. For that I am going to use the transformations R2 plus 2 times R1, because when I do that I will get minus 2 plus 2 equal to 0, and then I apply the transformations R3 minus 3 R1. So if I apply it here, I'm going to get 0 here because 3 minus 3 is going to give me 0. So after the transformations are applied, this is my resultant matrix. Okay, so next what we do is on the resultant matrix, since these two are 0, now I have to make this 1 and this 0. So what I'm going to do is I'm going to actually interchange this row to this row. So I'm going to use that row transformation um, command as R23. So I'm interchanging row 2 and row 3. So once I do that, this is my resultant matrix. Again, you can keep on pausing the video and check if this is correct. Once I do that, I'm going to use the next row transformation, that is R2 by minus 2, which transforms this matrix into this form. So you can see that now I have 1 0 0 and 1 here. So now I want to make this into, I want to convert this into 0. So for that I have to use the row transformation as R3 minus 5 times R2, which gives me this particular matrix. Please pause the video and check all the calculations. I want you to do it on your own and get the matrix from here to here. Okay, once I get this matrix, now the task is up to this. Now the next task is to convert this to 1. and for that I'm going to use this particular row transformation, and you can see that I got this because 4 upon 4 is 1 and 12 upon 4 is 3. So I've got this matrix now. Now the next task is to convert these two entries to 0. So let us see how to do that. So for that I'm going to use the row transformation as R1 plus R3 and R2 plus R3. So because when I add this, if I add this to this, I'm going to get this as 0 and all other entries remain unchanged. Similarly, when I add R1 plus R3, I get 1 plus 0 is 1, 2 plus 0 is 2, and minus 1 plus 1 is 0. So when I perform these two row transformations, I'm going to get this resultant matrix. So I'm almost done now. Only I need to now convert this to 0, and for that I'm going to use this particular row transformation, and then I finally get this matrix. Here you can see that I have converted A to identity matrix, and in the process B also got changed to say B1, and therefore as the theory says this is our solution, and therefore solution is xyz is equal to 1 2 3. I advise you to solve more example using this method. So these examples are available on the Moodle site. This is the link of the Moodle site, and this is ID, user ID and password. There are more quizzes. There are other resource material available there. One more thing, again, Scilab codes are also available on Moodle for different methods that we have learned. So you can use those Scilab codes, and please check if the answer that you get by manually solving the system of equations using these different methods and with the computer code. And that's all for today. Thank you.